Now, so any questions before I actually move forward?
Professor Chen, how
Yeah.
do we submit the assignments by handwriting or?
Yeah, that's a good question. Again, I'm gonna post the assignments on the Blackboard, and I expected that you're gonna, submit your assignments on the Blackboard as well. So, Blackboard is the main actually platform we're gonna use. You know, besides the Google Meet. Google Meet is like a virtual classroom. Blackboard is a tool we're going to use. So you're going to check the assignments on the Blackboard, and also, if you have never used a Blackboard before, I tell you, it's kind of very straightforward. So for the first assignment, you can log in there. The homework is already there, so you can submit your homework by uploading your work. Okay. So and also, yeah, this so the assignment is going to be um, on the Blackboard, and also the test. Um, haven't figured that things out, because I can actually post the test on the Blackboard, so you can actually take the test online. That's one way. Now, in certain cases, because I some of the assignments I want you to draw some of the diagram. So far, I haven't figured out the best way to do so, because you know in the past, for some of the assignment, people just draw this diagram like the circuits and all the diagrams on piece of paper, and scan it and upload it. That's one way. In my teaching, I can use the tool. I have a touch screen, so I can just draw this on the um, either on Microsoft OneNote or the Google Jamboard. Jamboard is one of the tools. So I can even draw everything on Microsoft Word document. I can use the touch screen to draw it. It's pretty actually powerful tool. But in the test, um, so I probably get, sometimes I can give you the online test. Sometimes I just, you know, maybe just post the test problem on the Blackboard. So you can download just like a homework assignment, and then I will give you certain period of time. For example, we can set up a test time, say, okay, next Wednesday from 8 o'clock to 11 o'clock. For example, I give you 3 hours, or maybe a little bit more times. So then, I'm gonna post the test problem on the Blackboard, make it available on the Blackboard between 8 o'clock and 11 o'clock. So you can download, and you can work on whatever the way you want, and then you can upload your work. Okay. So we'll figure out the best way to do so. And
Okay,
yeah,
thank you.
yeah. Any other questions?
Bradichand, this is Venkat. Actually, I just it's a simple question. Actually, you mentioned in announcement as no textbook. So you mean to say that your handouts and presentations is good for us, or how it works actually? So, and you
Yeah.
are given us
All the material is going to be in either the handout.
Mhm.
I'm gonna post the handout.
Okay.
Okay, so you can read it, and also uh, also the PowerPoint presentation. But PowerPoint presentation is just an overview. It's just summary, but you can read the handout. For each module, I'm gonna post the handout. You can read that one.
Okay.
Now,
And for adding to this, sorry, actually, you mentioned even the reference books also. So you mean to say that if you have any, if I have any doubt, I need to reference these books, or how it goes actually?
okay, so yeah, that's a good question. If you refer, so if you actually get any of the book, the reason I don't use the textbook is because I only actually cover very small portion from these textbook. So it's not worthwhile to get the book. So that's why I used a different material, because that book covers some of the materials, but not all of them. So
Thank you,
yeah.
Brian.
Yeah. So I don't recommend to spend money to buy this book. If you have any book you can borrow from someone, then you can use them. It just provides you some of the topics and the materials, but it only covers some of the material, not all of them. So I just to make I just to create all these material by myself from various different sources. So it's a we're going to cover a various different topics, from, it's not in the same area of math. So yeah. So yeah, if you actually read my handout, if you think it's too brave, or you want to know a little bit more, then you can always search the website to get more. But I think technically that the handout should be enough. I'm not going to actually give you more, give you any assignment problems which is outside this range. Yeah. So maybe in the class, I can talk, give you some examples which is not covered in the handout, but the material itself going to be in that, in the handouts I give you. So it's I'm not going to actually give you any problems outside this range. Yeah.
Okay. Got it.
Okay. So so this is actually the it look more like topics in math that used in computer science. So so here are the course objectives. We can actually learn some of the basic concept of calculus, linear algebra, probability, and theories. So I try to cover as much as I can, but depends on how much time we have, and also how much time I'm going to spend on each of the topics. So that's why I may not be able to cover all the materials, but I'm pretty sure I'm going to cover most of the material listed here. So and talking about Blackboard. So Blackboard will be used for posting announcements, schedule changes. If there's any schedule change, I'm going to post on the Blackboard announcement. And for any cancellations, grades, and also I'm going to post the grades on the Blackboard. So right after I grade your homework assignments, then I will post on the Blackboard. You can immediately see the result. Okay. So please check the Blackboard on regular basis. That's basically the place you need to go to get the most of the information for the class. So now the other thing you probably want to know about is how I'm going to grade your work. I will give you actually 10 assignments. Okay. So I think I'm going to provide like 10 to 11 modules. Now for each module, you will receive an assignment. The assignment basically contains the questions and exercises. Okay. And I also will give you some quiz problem. Now quizzes are very similar to assignments, but for assignment, I normally give you like at least a week to work on the materials. But for quiz, I basically set up a time and say, okay, today from 12 p.m. to 4 p.m. I give you like 4 hours, so you can actually finish, these set of, questions. So the quiz problem going to be very similar to assignments, but it has a very short period of time. Same are the tests. But the test it's more comprehensive. Quiz is basically covers a small area. And also the final exam. So these are basically how I'm gonna grade. Now each assignment, I will basically grade on the base of, on the basis of 10. So, but eventually, each assignment takes only 4% towards the final grade. So this is actually the weight for each of the assignment. So it's a 4, 4, 4, 4. So when you add all these together, you got a 100. So, okay. So pretty much after I've, graded your work, you can probably figure out, what's your grade going to be, if you actually check the grades for your assignments and the tests, you can pretty much guess, what's the final grade going to be, Okay, so this is actually the grading, chart. So you can take a look. So for quizzes, you were given 24 hours to complete. And so normally I will post the quiz on the Blackboard at 10 p.m. like Easter time. It depends on where you are. So I'm always just use the Eastern time. If you are actually living in the West, then it's probably they're probably the 4 hours delay. For example, in California, if you're in other country, then the time difference is going to vary. So if I give you actually like a 10 p.m. I posted the quiz problem, then you need to submit these quiz problem by 10 p.m. next day. Okay, so that's basically the one. But the test is actually similar to the quiz, but you have to finish the test within 3 hours. But for most of time, when I give you the test, so I give you 24-hour window to do the test. So which means once you start the test, okay, but you need to finish within 3 hours. But that's for the online test. But if I actually gave you the test posted online and you download and work on this, then I cannot do that. But if it's actually, if it is an online test, then I will normally set up that way. But I will let you know before each of the tests whether it's online or whether I just post it on the Blackboard, so you can finish within certain number of hours. So the main concern I have is, for some of the problem you need to draw this circuit, you need to draw these diagrams, and so I find out, not everyone has the tool to draw this digitally. So that's the reason I have to compromise this, and instead of to give you the online test, I have to give you the, just send the problem to you, and you can finish within certain hours using whatever the way you like. Okay, so that's something we're gonna discuss later. Before the test, I'm gonna talk to you. Okay, now this is the final grade assignment. So based on all these assignments, quizzes, tests, final exams, so I'm gonna actually give you the grade based on 100. Okay, so if you actually did everything perfect, you get 100. So now you can basically get 4.0 for the Fitchburg State University grade. Actually, not just 100. If your grade is actually great, more than 93, then you got a 4.0. And then if your grade is, basically between 90 and 93, then you got 3.7. So this is actually the mapping, between the class grades and the Fitchburg State University grade. Okay, so just let you know that I just published it here. Okay. Now, this is actually the class schedule and assignment. It's not complete. It's not done yet. Okay. So I try to actually give you the overall picture in terms of, how the class is going to be organized. So these are the meeting dates. Okay. So today is 27th. So this is the first day. And then we have, next meeting is actually February 3rd, which is next Wednesday. So we meet actually every Wednesday. Okay. So these are the total meeting time. So from January 27th to May 12th. Okay. So I try to actually list all the, give you the timelines in terms of in which particular day we're going to cover which material. So, but this is just to give you the some kind of, overall picture. The actual schedule may not be exactly like this. So for example, if I think, or if we find out, we need more times for module 4. So here I only actually give just one day to cover module 4. But if we find out, if you have a lot of questions, you have a lot of actual concerns on module 4, and we find out we probably need more than one day to cover module 4, then I'm probably going to actually make a slight adjustment for the time. So this just give you some kind of overall picture. Okay, just give you, some kind of idea at which particular time we're going to cover which material. Okay, but the actual schedule probably going to be slightly different. Okay, so I'm probably going to fill up the rest of the empty area, and so I may actually update the syllabus a little bit late. Okay, I got one more people join. Okay, now, so for each assignment, I will give you the due date. Okay, just actually keep your eye on the due date. Okay, now if you miss the due date, you're still gonna be able to submit your work. Actually, I encourage you to submit the work even if you miss the due date. However, you will get some small penalty for missing the due date. Here's the formula that I'm gonna use. If you missed one day, okay, for every day the assignment is late after the due date, I'm gonna deduct 5%, okay, from the assignment score. So if you miss a couple of days, if you miss one day, you don't miss much. You only actually missed 5%, So just don't give up. So every time you have a problem with your assignment, don't give up. Just actually keep doing. But actually, I'm gonna give you more times to do the homework, at least 1 week. Once I give you the assignment, the due date is gonna be a week later. So you have at least 1 week to do the problem. If you got any problem questions, you should have a time to ask me or discuss with other people. Okay. Assignments submitted 6 days after the due date are subject up to the penalty of 40% deduction. Okay, I hope not. I don't think we're gonna have a programming, because in the past I may give you people some programming work, but because this course has no prerequisite, so programming skill is not required to take the course. So I'm probably going to remove this line. So if programming is required, you must submit the source code. Honestly, there will be no programming assignments. So I'm going to actually delete that part. So don't worry about this. Okay. Now, collaboration and other issues. I'm not going to spend much time on the academic dishonesty policy, but I want to tell you the difference between collaboration and cheating. Now collaboration is encouraged. So if you have any questions, any problems, you can discuss with your colleagues, with your classmate, or you can even, set an appointment with me. So you can discuss the problem with me. Okay, that's encouraged. However, you cannot submit other people's work. You cannot actually take other people's work and submit as your own. That's that's a cheating. But collaboration is different. You can ask the questions, you can discuss, get some idea, but you still need to do the work by your own. Now, if I find out, you are actually, in many times, if you submitted correct, so maybe I cannot tell whether you actually cheat or not. But I actually sometimes when during in some of the class, I find out some people submit the work. It's a digital copy, but they submit the work. They even fail to change the name, some other place. So that's, if I find out, so then in that case, I'm not going to try to figure out who actually copied who, but both of you going to get a 0 for the assignments. Okay. Okay, I think that's pretty much all I want to talk about for the class. Now, before I move forward, do you have any questions?
Hello, Professor Chen.
Yes.
Do we have any format for the assignments?
But do I have any, what do you say? Any
Format.
Pardon me?
She mentioned format. Any format.
Oh, no, I don't have any format. So when I give you the assignment, I mostly post the assignment on the Microsoft Word document. So you can basically type your answers on the document. But I actually sometimes I receive some kind of assignment. People actually write on piece of paper and scan the paper. That's okay. I can take that one. Scan into a PDF file, Microsoft Word file. Most of the popular format should work.
Okay.
Yeah.
Thank you, Chen.
Yeah. Okay. So if you have any question, if you just interrupt me anytime in the class. So as I mentioned that the syllabus is the one you can check to see the class syllabus, and the course document. You'll probably see for each module you will see the module 1.pdf. That's basically the PowerPoint presentation, and the second module is the second one is a handout. So if you click it, you will probably see the material and you can read that material. Okay. So normally I'm gonna post these material just right before the class. Homework assignment. Let me see. Yeah, assignment is here. You can click the assignment. You can see the assignment. So the assignment is actually basically I'm gonna actually post the assignment on the Microsoft Word document, so you can check the problem over here. Okay. So let's let me actually stop the presenting and I switch to I switch to another one. Let's see. Okay. Can you see my presented material? Okay, let me.
I see it fine.
Okay, so that's good. Okay, let me see here. Okay, so let's see. Okay, so welcome to CSC 7013. That's the Advanced Math for Computer Scientists. Well, let me actually talk about a little bit. Talk about something else. This picture is actually the Edgley Hall. That's the computer science building. In the third floor, actually basically housed all the offices for the faculty of computer science and math. And the second floor and the first floor, it's actually, it's the building is actually built on a hill. So this is the back of the building. The front side is much higher, so it looks like on the back it looks like a basement, but on the front side it looks like a first floor. So it's actually built on a hill, so you can see the building. So I hope that after the COVID, then we have a chance to meet in my office and meet in our classroom. But unfortunately, for this semester, most of the time we're going to meet in a virtual classroom. So this is the Edgley, and now this is also an Edgley Hall. This is actually the front side, and the picture was taken 100 years ago. So now the front side is not the trees and the glass. It's actually a street. So you're probably going to see the difference. But that's the front side. The building itself is still the same, but everything else has been changed. Okay. So now let's talk about the first module. Now, before I actually start the topics, let me actually just ask you one question. So now, for most of the evening class, it's scheduled on either from 5 o'clock to 7:30. It's a 2.5 hour, and or from 7:35 to 10:05. So it's 2.5 hour. Now, so typically we're gonna meet like a 1 hour and 15 minutes, and then there's I think probably like a 15-minute or 20-minute break, I believe, and then we're gonna start another section. I think that's so. Let me see. We normally have a small break in between. So so what do you think? If do you want to continue the class, then we can finish the class earlier, or we want some kind of break in between?
Professor?
Yes.
Yes, I have a class from 5 to 7:30 with Natasha. I think she's probably going to only run from 6 to 7:30.
6 to 7:30. Okay. Now,
Actually, she said like until 7:15 today, Natasha.
Okay.
Now, it's kind of different, because normally the class time, because if we teach the class on a regular, schedule, that's 2.5 hour, and we have a small break in between. But because right now during COVID, the class is taught remotely, so every faculty can have their own schedule. So in my case, I may actually start. I still want to start from 7:35, but I may actually finish a little bit earlier. Depend on how much material I'm going to cover. So it's up to us. It's very flexible. But 2.5 hours is the maximum time, but actually it will be smaller, so okay. Yeah.
Without break is good, I think.
Okay, so let's actually start the first topic, the module 1. So as I say that we're probably going to cover like a 10 to 11 modules. So the first module we're going to cover one of the very important math topics. It's the Boolean logic. Okay, so here's the learning objectives for that module 1. So we can talk about truth tables. We're also going to talk about various different formula, including the De Morgan laws, and then we're going to actually talk about some kind of a proof technique. In very important part of math is the proof. You want to prove some kind of a theory, some kind of a factor, and we're going to actually talk about some kind of techniques for the proof. So also we're going to talk about, provide some examples of demonstrating logical equivalence with truth tables. Okay. Now, math logical is very, very important and also a very classic topics. And then we find out in computer science, this math logical is very important, very useful, because eventually when we talk about modern computer technologies, particularly like AI, artificial intelligence, we just try to actually use the computer to simulate some kind of human logic. So that's the reason why we try to actually start from the math logic and like a Boolean logics, try to figure out how can I make the computer to think, to do something based on certain under certain conditions, make certain logic, so the computer can recognize these logic and perform the job. So we just try to train the computer to think like us. So that's why we want to study first like a human logic, and then try to, so basically mathematicians always try to use the formula to record these logic. So okay, now the first thing we're going to talk about is a propositional or Boolean logic. Okay, so when we talk about propositions are basically theorems of, or we try a factor, or we try to describe or denote something, right? So when we say a particular sentence, when we actually describe a factor, then we try to make a judgment to say whatever you say is true or not. Okay, so basically propositions are either true or false. It's just the same kind of a statement which has a value. The value is either truth or false. Okay. If a proposition describes something which is the case, then it is true. The value is true. Now, if the proposition describes something which is not a truth, not the case, then the value for the proposition is false. Okay, it's a false statement. One of the example is, for example, we can say the capital of the United States is Washington, D.C. Now that's a proposition, right? That you just try to describe something, Now, then we can figure out whether this statement is true or not, and then we need to check whether this is the case, whether this is really the factor. Is the capital of the United States Washington, D.C.? Now, the answer is true. It's correct. So that basically means this proposition has a value true, right? It's not a false statement. So that's basically the proposition. So you can always, in our real life, you can always find some kind of statement. You can actually make your judgment whether this statement is true or not. Okay. So now the reality is not all the statement has a value, but in many cases, if someone says something, you can either make a judgment whether he's telling the truth or not. Now, in that case, we basically define these as propositions. Okay. So so when you actually say something, now the proposition could be very simple statement, or it's a little bit complicated statement. Depend on the situation. Now, for example, the capital of US is Washington, D.C. That's just the one simple statement. But sometimes you're probably gonna, try to say something which contains more than just one statement. And so in that case, we have to use some kind of operations, or we sometimes called connectives, to connect two simple statement into a more complicated statement. Okay, so this is what the mathematicians try to build, from very simple statement to build a little bit more complicated statement, and then from a little bit complicated statement to build more complicated statements. Okay, so now the tools basically they use, all the operations they use are one is called conjunction, or in English we just use and to describe the operation. Okay, so it's an and. Okay, the other actually operation is called disjunction, or it's called or. Now, implication is a little bit more complicated. It's basically use the English if something happens, then something else happens, and that's called implication. Negation is pretty simple. Basically, in English, it basically means not. Okay. So, for example, if one of the statements say, "My name is Brady," okay. So if I say my name is Brady, okay, that's a proposition. Now you can judge whether this is a true statement or not, right? Negation basically just put the not, on the whole statement. So now in English we can interpret this like if my name is Brady, and if I put a negation here, that means usually you can interpret, say, you try to say my name is not Brady, right? Or it's not true that my name is Brady. So so whatever you can do is you just it's just actually the opposite of this statement. Okay. So that's the math term: conjunction, disjunction, implication, negation. Or in English, it simply just means and, or, and if, then, or not. Okay. Now in math, we also use a notation. So we use this to represent a conjunction, and this represent a disjunction, and that's a negation, and this is an implication. Okay. So that's the math notation. So, the mathematicians always try to use some kind of English letter or some variable to represent something, right? Even the proposition, they try to use English letter to represent this. proposition. So for example, my name's Brady. Now, if you try to actually, use the proposition many times, then I try to define a variable I call the x, and to represent that statement. So every time when I refer x, I know that x basically means my name is Brady. X has a value called my name is Brady. Okay. So now with these operations and also these notations, we can actually somehow use the math expression to describe some of the proposition. For example, one of the propositions says, the capital of the for example, let me see what is the statement. Okay, I'm gonna say one of the statements says, let me try to what I'm gonna try to say. Okay, so for example, when I try to say Paris is a capital of France, and London is a capital of UK. Okay, now it looks like this is actually two. It's a proposition which contains two simple, statement. For example, Paris is a capital of France. Okay, so then this is one statement. London is a capital of UK. That's another statement. So then you can combine these two statements into a little bit more complicated statement. Then you say Paris is a capital of France and London is a capital of UK, right? So in this particular case, if you want to, now here's one of the examples. Okay. Now, this is actually something we use in English. Okay. Okay, let me. Okay, so let me just. So this is the statement. Okay, the proposition, the statement. It is not the case that the John is married, and the John's wife is not married. That's kind of a very strange statement. John is married. John's wife is not married. Okay. Okay. It doesn't make sense, right? But but this is actually a legitimate, statement. Even though it doesn't make sense, but it's a legitimate statement. Now, if we try to use the symbolic form to describe the statement, what can we do? Okay. So we can basically make assumption, we can assume that I can use a particular variable A. A basically stands for John is married. Okay. So let's say A. Okay. Now I can use B, says basically stands for John's wife is married. Okay. Mathematician always try to use some kind of a variable English letter to represent something. Okay, use symbols. Now, how can we simplify this statement? So it looks like that John is married. Okay, that's just one statement. So it's A. And that's more or less like the disjunction, right? And conjunction, right? And so looks like the English and looks like conjunction. And now we use the conjunction. We use this, to represent a conjunction. I don't know how to call this symbol. So looks like John is married and John's wife is not married. So B basically, if I say A and B, that this is not right? Because that does not represent that statement, because it says John is married and John's wife is not married. But A and B basically means A is John is married, okay, and John's wife is married. Okay, so that's not basically what it means. So John's wife is not married. So how can we use this operation to represent John's wife is not married? If I still use the, this notation A, notation B. So if B represents John's wife is married, now how can I describe when John's wife is not married? What kind of operation we can use? Let's go back.
Negation.
So these are the 4 operations we can use. We can use negation, right? So that means if I use negation, B basically means John's wife is not married. So I'm not gonna use this here. So what I'm gonna do is I'm gonna actually erase this. Okay, so I'm gonna put these say I can put the parentheses over here. So John is married and John's wife is not married. However, it still does not represent that statement, right? Because the statement say, this is basically say John is married and John's wife is not married. But this statement says it's not the case that John is married and John's wife is not married. Now, what does that mean? So that means I'm going to put another parenthesis and put the negation here, the whole thing, right? So that means John is married and John's wife is not married. Now, it's not the case. That means you basically completely the opposite of this expression. So then I use negation. Negation basically means it's the opposite of the statement. Okay. Now that statement is here. John is married, John's wife is not married. But now it's not the case means it's completely opposite. Okay. So that means, we have this to represent, John's wife is not married, using negation B, and then A and negation B. So that means A conjugate conjunction not B stands for John is married and John's wife is not married. Okay. Now to clearly express, represent this whole statement, you're going to put the negation for the whole statement. So basically that statement stands for it is not the case that John is married and John's wife is not married. Okay. So that's basically the Boolean logic and the operations we actually use. Okay. Now, so each variable A, B basically represent a kind of statement. That statement could be any kind of statement in our life. that has the value truth or not. Okay. That's one of the example. And now, so here we basically shows that we can represent any statement, use the math expression using symbolic form to represent any kind of statement. If you're given a statement, you try to identify inside this complicated statement, what is the simple statement? And you try to isolate each of the simple statement and try to figure out what kind of operation we actually use to combine these, simplified statement, that makes that a complicated statement. So this is actually something we try to find out as a mathematician. Okay. So from math perspective, we can simplify many of the things in our real life into just some kind of math symbolic format. Okay. Now, truth table basically is the one we're going to discuss. Okay. Now, if we have a complicated statement, and normally sometimes we call it a compound statement. Okay. If the compound statement is actually built, if the compound statement is built upon the simple statements, like A, it's a simple statement, B is a simple statement, and then we just use the operations like a conjunction, disjunction, or negation to build a very complicated statement, a compound statement. If we use that, operation to build a compound statement, then we hope that based on the value of a simple statement, we can actually find out what's the value, whether it's true or false, the value of the compound statement. Okay, this is something we try to build, and that's called a truth table. Now, suppose we have two simple statements, P and Q. Okay. The operation we try to define is AND or conjunction. Okay. Now here, so we try to use the notation, if the statement P is truth, then we normally use the number 1 to represent the truth. And if it's a false, we use 0. Okay. Now, based on this, we can build a truth table for the conjunction, the truth table for the disjunction, and the implication and negation. And now these tables are built based on our life experience. Okay. So these tables are built upon our life experience. We can explain this. For example, if the value of P is 1, value of Q is 1, then P and Q is 1. Okay. Now value of P is 1, which means true. Value of Q is false, then P and Q is false. And if P is 0, Q is 1, it's 0. If P is 0, Q is 0, and then P and Q is 0. Now, if you think about this, P is actually some kind of statement in our life. And AND is just an English AND. So does this truth table make sense to us? Now, for example, if I have one statement say, okay, my name is Brady. Okay. That's one statement. That's P. Okay. And another statement to say Q. I'm living in New Hampshire. Okay. Now, you know that's true, right? Now, but suppose this I'm living in New Hampshire, that's false. Okay, that's true. Or that's 1, that's 0. I'm sorry, that's true. Okay. Now, if I say P and Q, that means my name is Brady and I live in New Hampshire. Now, if for each individual statement, my name Brady is true, I'm living in New Hampshire, that's false. So then the compound statement say P and Q. That means my name is Brady and I'm living in New Hampshire. That's false, right?
Yes.
Because it doesn't really matter the first statement is true, but the second statement is false. So if we use and, that means if one of the statement is true, false, then the whole statement is false. So if you actually try to say something in a court, for example, so you say a lot of things, blah 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 blah, tell the truth, and suddenly you lie in one thing. Now the judge is going to say you lied, right? He's not going to say, or she's not going to say, oh, you say this is true, but you lied on one thing, so that means you're basically lying, you know. So that's basically, you know, the how this table is, you know, built upon. Okay, that's conjunction. So the only case that the compound statement is true is that the both statement is true. Okay, if this is true, then the compound statement is true. If one of these is false, then it's false. Now, it's also easy to understand the other operation, the disjunction or or statement. Okay, so that means if P is my name is Brady, Q says I'm living in New Hampshire. Okay, so then I'm gonna say my name is Brady or I'm living in New Hampshire. So when people judge the whole statement, they just need to figure out whether any one of these statements is true. Then I'm gonna say the whole thing is true, right? It doesn't matter, you know, you lie on this, but at least I found one truth statement. So the only case for the or statement is if both statements is false, then the result is false. As far as one of these is true, then the result is true. Or if both are true, then it's of course it's truth. You know, the compound statement is truth. Now, implication is a little tricky. Okay. When you build that table, you're probably going to figure out how this is the case. Okay. Now, let me explain this for the implication. Okay. Now, if I say for the implication, let me actually just bring up the a Word, Microsoft Word document. Okay. Now this is the implication. The implication says if P is true and Q is true, then P imply Q is true. What does that mean? So let's say if P is, the statement says you get 4.0. Okay. So if you take a course and your final grade is 4.0, okay, that's a statement, right? And now you can easily check you get 4.0 in the particular course or not. If you get 4.0, then that's true. If you don't get 4.0, that's false. Okay. Now Q, I will give you $100. Okay, that's another statement. Now you can also easily judge whether this is true statement or not. If I gave you $100, then Q is truth. I'm telling the truth. If I don't give you $100, then I'm lying. So P imply Q. What does that mean? So that basically means if you get 4.0, then I will give you. Okay. So that's basically what does this implication means. Okay. Okay. Now what happens? If P is 1, that means you get 4.0, right? You get 4.0. So P is 1. Now, then I actually give you $100. So that means Q is 1. So then if you get 4.0 and then I give you $100, this whole thing is true, right? This actually happened. It is the case. Okay. So this is easy to understand, the first one, right? It's kind of easy to understand. Now, what about this? If P is true, okay, so that means you get 4.0 and I did not give you $100. So that means the whole thing is not the case. So that means the whole thing is false, right? Okay. Now the last case is, this first two cases are kind of easy to understand, right? Now what about this case, last case? Now, if P is 0, Q is 0, okay, you did get the 4.0. So I did not give you $100. I did not violate my statement, right? So I just say, if you get 4.0, I gave you $100. If you don't get 4.0, if I don't give you $100, you don't have to complain. So this whole thing is still true, right? It's fine. If you don't get to $100, then of course I have no obligation to give you $100. Okay, so that's fine. Now what about this case? If you did not get 4.0 and I still gave you $100, right? Okay. How can you explain why the whole thing is true? Now think about this. Use our logical in our life. Now, if you fail to get 4.0, it really doesn't make any. It really doesn't matter whether I gave you $100 or not. Whatever I do, it makes sense, right? So if you don't get to 4.0, I can always say that statement always truth, because it doesn't matter whether I gave you $100 or not. If I give you $100, then it's still actually true. So it's fine, because I never say I'm not going to give you $100 if you don't get 4.0. I only say if you get 4.0, I will give you $100. If you don't get 4.0, I did not say I'm not going to give you $100. So I'm not violate anything, right? So, but if you don't get 4.0, if I don't give you $100, you still don't have to complain, right? So either way, whatever I do, it's always right, right? So that's why in this particular case, the only thing result the false is if this is true, I promise you get 4.0, I gave $100, but you got 4.0, I did not give you $100, then I violate the thing. So the whole thing is false. But if you did anything wrong in the first place, it doesn't matter what I do, right? So it's always true. Okay. So this truth table is built upon our life experience. So you can interpret this as a truth. It's always the case. Now, the negation is easy to understand. If P is truth, and then negation and not P is false, right? If P is false, not true is, and not P is truth. So just keep that in mind. Always remember that truth table. Whenever I do, you always need to use the truth table. Now, with the truth table, then we can build a more complicated statement, a compound statement, and we can always make it true. Now, here are the facts. Here are the facts on the truth table. When a conjunction is true, if and only if both conjunctions are true. So that means A and B is true, then if and only if A is true and B is true. If one of these is false, then the whole thing is false. Now, disjunction basically, or statement basically says, if A or B are false, then both A and B are false. So if this is true, then you just need to make sure one of these is true, or both of these are true. That's fine. Okay, that's not a problem. So implication is false if and only if the antecedent is true and the consequent is false. So if you look at this, this is true, this is false only when this is true and this is false. Okay. In any cases, the implication always result in the true statement. Okay. Negation is actually pretty simple. Negation A is 1 if and only if A is 0. Or negation A is 0 if and only if A is 1. It's either way. It's always the case. So that's basically the math logic, okay? We call the Boolean logic. Because this theory is built by a mathematician called Boole, and one of the mathematicians called Boole. So that's why we call the Boolean logic, okay? Now, one of the important factor is it's something called De Morgan law. Okay. Now, De Morgan law is pretty simple. Now, if a P and a Q, the whole thing, the negation of the whole thing is the negation of P or negation of Q. Remember that in here, inside the parenthesis, that's and. Now, this is or. Okay. This is the and. Okay. Now you can actually try to use a lifetime experience. Like you can assume P is a statement. Say my name is Brady. Q is the statement like I'm living in New Hampshire. Then you can try to use this to represent the each of the statement. You can find out. This is always true. It's called De Morgan law. Now, how can I say this is always the case? Okay. Now, so you have in here, in order to make sure this statement is always true, you need a proof, right? How can I prove this? Okay. How can I prove this? How can I prove this is always true? If this is always true, then we can always use this interchangeably. So if you want to say P and Q And the negation of the whole thing is actually negation of P or negation of Q, right? So we can always do. Now in math, there are two actually proof technique. Okay, one is use the truth table. Okay, one is use the truth table. Now the other one is, we can prove by contradiction. Okay, we can make assumption if something you try to prove is not true, does not hold. Then we actually eventually leading to some kind of contradiction. That's another kind of proof. Okay, now use truth table is, the idea is very simple, but it takes some time. But use contradiction, sometimes it's easier. So let's actually take a look at some of the example. So let's actually try to prove the De Morgan law. Now you try to prove that the left side is the same as the right side. Now if P and Q are proposition or statement, right? So let's say what we can do is we're going to actually try to build a truth table. We just want to make sure we can choose the value of P and choose the value of Q, and we can calculate the value for the whole statement, right? Okay, now what kind of value we can choose for P and Q? Now because this is a Boolean logical, so the value for the P is either truth or false, right? Or either 1 or 0. And the Q is either 1 or 0. Now for P and Q, how many different combinations we may have? We can have, say, suppose if P is 1 and Q is 1, okay? And P is 1 and Q is 0. And P is 0, Q is 1, P is 0, Q is 0. For value P and Q, these are all the combinations we can have. Okay. Now, suppose P is 1, Q is 1. Now, we want to evaluate the left side, right? So in order to evaluate the left side, we need to evaluate P and Q. Okay. So if P is 1, Q is 1, P and Q is P. That's P or Q. Oh, I'm sorry. I think I'm wrong. So this is actually I try to prove this. And also the right side is this. Okay. 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 So P, if I try to actually P is 1, Q is 1, P and the Q is 1, right? Is that right?
Yes.
And if P is 1, Q is 0, what is P and the Q?
P and Q.
1.
0. 0.
It's 0. Because that's and,
Yes.
that's conjunction. Okay. 0, 1,
0.
0. 0, 0, 0,
0.
right? Okay. Now the negation of P and Q.
0.
Okay, sorry. That's all mistake. I just
That will.
that's 0. Negation of
1.
0 is 1. Negation of 0 is 1. Negation
One.
of 0 is 1. Okay.
Yeah.
So that means for P, the combination of value P is 1, Q is 1, the left side is 0, right? P is 1, Q is 0, the left side is 1. Now let's take a look at the right side. If we have to check for the same value. If P is 1, Q is 1, P is 1, Q is 1. We make sure that the if we want to prove that these are all the same, that means for every pair of value of P and Q, they're always the same, right? So P is 1, Q is 1. So what is negation of P?
0.
0. Negation of Q, 0.
0.
Now, 0
0.
or it's or. Okay, that's what we try to prove. 0 or 0,
0.
still 0, right?
Mm.
0,
Mm.
1.
1.
Negation of Q is 1. Now 0
0.
or 1.
1.
That's 1.
1.
1. 0,
0.
right? That's 1. Or 0. That's
1.
1.
1. 1. 1 or 1. That's 1.
1.
So I think that the presentation I actually posted on the Blackboard is wrong, because the the De Morgan law I tried to prove is here's the and, here's or. So but in the actual table I actually reversed this one, but I just corrected. I'm going to correct this. Okay. Now, to tell the truth, the De Morgan law also apply for the other side. For P, Q is negation P and the negation Q. So you can switch the order. You can put the and or inside. You can put the and inside. It's also true. Okay, you can also prove that. But this is one actually. That's also called the De Morgan law. But you switch the operation. So this is actually basically prove the De Morgan law by using the truth table. Okay. Now the other technique we normally use is called proof by contradiction. Okay. Now again, we try to prove the De Morgan theorem by contradiction. Okay. So what we try to prove is negation of P and Q is the same as negation of P or negation of Q. Okay, we just try to prove that this is always true. But now, proof by contradiction is the technique that we're going to use. Now, we're going to assume that if we can show that both of the following statements are true, then we can prove the De Morgan theorem. So, suppose if this is true, that's the left side. Okay, this is true, and this is false. We know that's not true, but in order to prove, then we assume that this is true and this is false. And hopefully we can actually get the contradiction, right? Okay, so now let's just assume this is true, okay? Let's go to the next one. So suppose this is true, okay? And this is false. Okay, so that's the first part. This is true and this is false, right? So we can actually say this is true, this is false. And I actually put this statement, I'm going to say this is A and this is B. So I'm going to say, so that's the same as this. This is A, this is B. Now we just try to say that's not possible, okay? Because we want to prove that's not true, right? So now, if that's the case, I'm going to say based on 1B, 1B says this. Now, negation P or negation Q is 0. What does that mean? By the factor. Because the factor, disjunction table says, if A or B is 0, then only on the if and only if A is 0, both A and B are 0, right? So if this is 0, that means the negation of P is 0. and negation of Q is 0, right? Because you have to make sure both of these are 0. Then we can get the final result 0. Okay. So if negation P is 0, then P is 1, right? That's by the factor for the negation operation. If negation Q is 0, Q is 1, right? Now what does that mean? If P is 1, Q is 1, then P and Q is also 1, right?
Yes.
Now if P and Q is 1, then from 3 and the negation table, we got negation of P and Q is 0, right? Now this is actually contradicts to this assumption, right? Because if that's the case, we actually finally result in the negation of P and Q is 0, which is not the same, which is contradicted to this assumption. So that means this assumption is true. It's not true, right? So that's impossible. Okay, this basically just to prove this one side. Okay. Now, in order to prove this is always true, we also need to prove the other actually assumption is not true. Okay. So suppose that the negation of P and Q is false, and so left side is false and the right side is true. Okay. Now, if we can also get the contradiction, then we can prove that this is true, right? This De Morgan theory is all, the De Morgan law is true. So this is actually another proof. It's not the same proof as the truth table. The truth table is very straightforward. We just pick all the possible value for P and Q and build the table on both sides. Okay, on the left side, on the right side, and we find out, both table result in exactly the same value. Okay, for value P and Q. But the proof by the contradiction, we have to just assume one side is true, other side is false. Then we result in contradiction. And one side is false, the other side is true, and we result in contradiction. And then we say that's not possible. So then you have to have this. Okay, that's the proof technique. And then the second part is, remember, it's the same. It's the opposite of the first one. The first one is that we already, I think I already proved that one, right? So it should be, okay. So we shall prove this. It's not possible. Okay. Suppose this now. Okay. I try to give you probably a 4 to 5 minutes, so you can actually get a piece of paper. Try to, prove using the proof technique, prove by contradiction. That's the second part. We assume that the left side is false and the right side is true. Then you get the contradiction. Okay. Okay. So I think I'll be back in 5 minutes. So. Let me